Article 310.15 B4 addresses conductor ampacity correction factors and adjustment factors. These factors are applied when conductors are installed in specific conditions such as elevated ambient temperatures or when multiple current-carrying conductors are bundled together. These conditions affect the heat dissipation capability of the conductors, and the ampacity must be adjusted accordingly to prevent overheating and potential fire hazards. The National Electrical Code, or NEC, provides tables and guidelines for determining these adjustment and correction factors based on the specific installation conditions. Article 310.15 B2 involves determining the allowable ampacity of conductors. Ampacity refers to the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. This table provides ampacity values for various conductor sizes, insulation types, and temperature ratings. It's a fundamental resource for selecting the appropriate conductor size for a given electrical load, ensuring safe and reliable operation of electrical systems. Now, consider a 120/240 volt alternating current open delta electrical system. This type of system is a three-phase power system that utilizes only two transformers instead of the typical three transformers found in a closed delta or Y-connected system. Open delta systems are often used when the full capacity of a three-phase system is not initially required, but there is a possibility of future expansion. In a 120/240 volt configuration, the system provides both 120 volt for lighting and small appliance circuits and 240 volt for larger loads like electric ranges, water heaters, or air conditioners. In an open delta system, the voltage relationships between the phases are different compared to a standard three-phase system, which is crucial to understand for proper circuit design and load balancing. The key aspect of a 120/240 volt open delta system is how the 120 volt loads are handled. Typically, these loads are connected from each of the two hot legs to the neutral conductor. This creates two separate 120 volt circuits that share a common neutral. The neutral conductor carries the unbalanced current between these two circuits. If the loads are perfectly balanced, the neutral current will be zero. However, in reality, perfect balance is rarely achieved, and the neutral conductor must be sized to safely carry the anticipated unbalanced current. The NEC addresses the sizing of the neutral conductor in various sections, taking into account the type of loads served and the potential for harmonic currents. Article 220 provides guidelines for calculating branch circuit, feeder, and service loads, which directly impact the required ampacity of the conductors. When applying Article 310.15 B4 and Table 310.15 B2 to a 120/240 volt open delta system with 120 volt loads, it's important to consider the specific context of these code sections. Article 310.15 B4 regarding adjustment and correction factors applies when conductors are subject to conditions that affect their heat dissipation. This could include bundling conductors together in a conduit, installing them in a hot environment, or using specific types of insulation. In these situations, the ampacity of the conductors must be adjusted to prevent overheating. Table 310.15 B2 provides the base ampacity values for conductors under normal operating conditions. These values are based on the conductor size, insulation type, and temperature rating. When applying these code sections, the following considerations are crucial. Firstly, determine if the conductors in the 120/240 volt open delta system are subject to any conditions that require ampacity adjustment or correction factors, such as bundling or high ambient temperatures. If these conditions exist, Article 310.15 B4 must be applied to adjust the ampacity accordingly. Secondly, use Table 310.15 B2 to determine the base ampacity of the conductors based on their size, insulation type, and temperature rating. This table provides the starting point for calculating the allowable current carrying capacity of the conductors. Thirdly, ensure that the neutral conductor is properly sized to handle the anticipated unbalanced current from the 120-volt loads. Article 220 provides guidelines for calculating the neutral load and determining the appropriate conductor size. Fourthly, verify that all conductors, including the neutral, are protected by overcurrent devices such as circuit breakers or fuses that are sized appropriately for the conductor ampacity. Overcurrent protection is essential for preventing damage to the conductors and equipment in the event of a short circuit or overload. In many typical installations of 120/240-volt open delta systems with 120-volt loads, the conditions requiring adjustment factors as described in Article 310.15 (B4) and may not be present. For example, if the conductors are not bundled together and are installed in a normal ambient temperature environment, the adjustment factors may not be necessary. Similarly, Table 310.15 (B2) provides the appropriate ampacity values for the conductors under these normal operating conditions. However, it is essential to carefully evaluate the specific installation conditions to determine if any adjustment or correction factors are required. If the conditions warrant, these factors must be applied to ensure the safety and reliability of the electrical system. Understanding the interplay between Article 310.15 (B4) and Table 310.15 (B2) is crucial for ensuring code compliance and safe operation of 120/240-volt open delta systems with 120-volt loads. By carefully evaluating the installation conditions and applying the appropriate adjustment and correction factors, electrical professionals can ensure that the conductors are properly sized and protected, minimizing the risk of overheating, fire, and other electrical hazards. Always refer to the latest edition of the National Electrical Code and consult with qualified electrical inspectors or engineers to ensure compliance with all applicable regulations and standards. In summary, Article 310.15 (B4) addresses ampacity adjustment and correction factors based on installation conditions. Table 310.15 (B2) provides base ampacity values for conductors. For 120/240-volt open delta systems with 120-volt loads, these sections apply if the installation conditions warrant it. Always consider the specific conditions and consult the NEC for complete guidance.